Hello, everyone. Welcome back to another session on wildlife analytics. We'll be continuing the session from the previous topics we have discussed, that is k-means. So today agenda will be discussing the code of k-means and re- understanding two use cases where k-means clustering is used, and basically clustering is used, and we'll see about the KNN algorithm and its features, limitations, and introduction, advantages, etc. So I'll quickly share my screen. Okay. So first we'll discuss the two use cases that we have with k-means clustering. Okay. Give me a minute, guys. Okay. So first use case we'll be discussing is okay. Use of machine learning to detect wildlife product promotion and sales on Twitter. Okay. Okay. So the first use case will be use of machine learning to detect wildlife product promotion and sales on Twitter. Okay, the problem statement here is identifying illegal sales of ivory and pangolin scales using Twitter data. And objective is to maximize the identification of sellers, and constraint is to minimize the illegal sellings. Okay, this is one of the use case that will be taking to and using k-means on it. So here, after knowing the business objective, its problem statement, objective and constraint, we okay, this use case is related to sales on Twitter. So it is a social media okay. I'm sorry. Okay. This is a social media important channel for communication, that is Twitter. Okay. Information dissemination and social interactions are also done here. But it also provides opportunities to illicitly sell goods online, including the trade of wildlife products. In this study, in this use case, we use Twitter public application programming interface, that is Twitter API. Okay, they use Twitter API to access Twitter messages. Okay, I will list all the things that they have done here. They have used Twitter social media, and they used Twitter API to access its messages, and messages to detect and identify or classify suspicious wildlife traffic and sale. So this is done using an unsupervised machine learning topic model. Okay. So here K means we are dealing with unsupervised machine learning, that is K means. algorithm. So we'll be taking this as a use case and going forward with it. Okay, here mostly these are all the use cases which we are doing. So here they chose two prohibited wildlife animals. One is elephant, another is pangolin. So elephants' tusks, which are also called as ivory, and pangolins' scales. Okay, so these data from Twitter is collected through keywords. And known code words. Okay, keywords and code words related to these both species. So in total, they have collected 138,357 pets. Okay, in Twitter, if you post anything, that if you refer it, it's called as tweet. So they have collected a total of 138,357 tweets through filtered keywords for 14 days period. Okay, this data was collected in in 14 days. They have collected these many tweets using these keywords and code words that are related to elephant and pangolin. Okay, illegal sex. Okay, so with this data, they were able to identify 53 tweets from 38 unique users. Okay, 38 unique users who were suspected, who were suspected to promote the sales of ivory products. Okay, but okay, 38 unique users, ivory products, but not pangolin scales. Okay, they did not detect any pangolin related sales. So the study result shows that machine learning combined with supplement analysis approaches such as those utilized in this use cases in this use case have the potential to detect illegal content without the use of an exciting training dataset. Existing training dataset. Existing means historical data. Okay. If developed further, these approaches can help technology companies, okay, conservation groups and law enforcement officers to predict the process of identifying illegal online sales and stem supply for the $1 billion criminal industry of online wildlife trafficking. Okay, so this is the basic introduction of one of the use case where they have used unsupervised machine learning model, that is k-means, to identify using keywords, code words, identify elephant, ivory, and pangolin sellings on social media, that is Twitter. Okay. So to further continue with this, this use case study is divided into 4 phases. Okay. That 4 phases include okay. I think so I have to compulsorily. Okay, the 4 phases include manual search. You can either search it manually, like give the code word in the search engine, search bar of the Twitter, and then search for the products. And next is data collection. You come across any of the searches like that related to pangolin and ivory, you collect that data. Third is data processing. And fourth is data analysis. You search the data manually and collect the data. And then there's, okay, you search the data manually through their social media search engines, and you come across any of the data, you collect the data. And then data processing is, you can tell that the data is already collected, why again process it? Okay, here they have mentioned you can use a keywords or code words, but there can also be tweets about how elephants ivory is being illegally sold. Okay, we can't tell that, since it is a social media, we can't tell that there's always sale if you mention these 2 words. Okay, there might be an article or tweet in a Twitter social media that someone is posting a tweet saying that elephant ivory is being illegally sold, so that is not right, or something the tweet says. So when you are searching with the keywords and code words in their Twitter search, this might also come up. And since you don't know that this is not related to it, you might also collect the data. So this doesn't give you a clear cut or information that this is the person or the user who posted it also is also selling the elephant theory. So that is why you do data pre-processing to eliminate such kinds of falsified bits. Okay, and after doing it, you do your data analysis. You analyze the data and you go on with it. Okay, So manual search strategy here is the first phase of their study involves conducting manual keyword searches directly on Twitter platform, as I told you all. And the objective of performing manual search was you can select proper keywords to be used in the data collection phase. And the second objective was to select sub keywords or keywords used as filters in data processing phase. Okay, so the data collection, as I already discussed up, uh, it was after doing the manual search, they selected two distinct groups of associated keywords, that is ivory and pangolin, which were used to filter tweets from the Twitter public API for over 14 days. Okay, our keywords includes, so their keywords included the species related keywords. In addition to the text of the tweets, other metadata, so like example, geolocation, time, followers, how many are following them and how many followers they have, etc., etc. Each post also were collected to get an idea of how many are actually buying it and how many, if they're following that particular person who is selling illegally, then they are potential customers or buyers. So if you want to catch hold of them, this information would be very useful. The geolocation, time, number of followers, or whoever that person is following, okay, etc. And in come to data processing, they analyzed tweets using IBTM, which is an unsupervised machine learning topic model that use natural language processing to categorize short forms of text to a given number of groups. Okay, here they have used natural language processing mainly because the tweets are always in a text format. So they have used natural language processing. But after analyzing the data from the tweets and getting the information, they used k-means clustering to group the data into ivory and pangolin. Okay, so that is how they were able to identify the sales or categorize the sales on how much it is happening. So the total conclusion of this is detecting online wildlife trafficking is a race against time with criminal actors. Or especially online traders can self delete information contained in social media. Yes, we already know, we already use social media accounts where we can delete our content. So what do they do is they can delete their accounts as soon as the sale is done. They delete their posts or the account as soon as the sale is done or after the trade is completed. In response, many wildlife conservation organizations and tech companies are reportedly taking action to combat wildlife trafficking online with the coalition of coalition to end wildlife trafficking online representation in such examples. So here Importantly, machine learning approaches to quickly detect sales and immediate action by platforms in conjunction with digital surveillance and in partnership with law enforcements. So these are all involved in the action to combat wildlife trafficking. Okay, this particular study provides a potential approach to part of this challenge. Okay, here they have used elephant ivory and pangolin scales, but if this model really works, instead of elephant ivory and pangolin scales, in addition to that, they can also use other illegal activities that are going on. Example, animal skins. Yes, poachers, hunters, they don't only go for elephant ivory, they also do other illegal sales, illegal businesses, etc. So we can also identify those. So, how can we improve these approaches and enable scale ups of technology based solutions? So, is by using machine learning and artificial intelligence. But one of the key challenges that needs to be addressed here is lack of harmonization of international policy and national legislation around conservations and wildlife trafficking. So, detecting online wildlife trade is just the first process in combating the illicit trade. So, critically, further analysis is required to determine if a scale or offer for scale is in fact illegal, particularly if applicable legislative varies based on the jurisdiction of the seller or type of species. Some of the examples like that are the scale of ivory products are prohibited in almost all countries. However, Japan is a notable exception. Additionally, even under the Convention of the International Trade in Endangering Species of Wildlife, Fauna and Flora, a multilateral treaty that entered into force on July 1st, 1975, and currently enjoys membership from 183 state parties, actual implementation of treaty obligating obligations. So we have to look into all the state and nationwide policies to see how to check whether the illegal sales. Suppose Twitter is a social media for all whole world. So if one particular person from say South Africa is selling a product, we have to first go back to their rules and see if that is allowed. That person is selling illegally or not illegally. Is the country allowing them to sell them or not? If the country is allowing them to sell those products, then it is not an illegal trafficking. Yes. So that is how these are all the challenges that are being faced and the limitations. So this is about the use case that we discussed, that is use of machine learning to detect wildlife product promotion and sales on Twitter. So hope you all understood this use case. We'll be coming back to another use case in a couple of minutes after we understand this code of how k-means clustering is used in wildlife. Okay, as in the previous session, we have done an EDA on tick distribution. We have done EDA pre-processing And we also did auto EDA, okay, for all the graphs and stuff, etc. So, first here, we'll import necessary libraries, that is pandas and numpy. Pandas is to read the file, that is tick distribution. Okay, here we have taken day, season, farms, year tag number, sex, age, stocking density, body condition score, and tick distribution percentage. Okay, the data which we saw yesterday. And then we are describing the data, describing into count, mean, standard deviation, minimum, maximum, 25%, 50, and 75%. Okay, and we are reading the info of this data. We are checking for the correlation. In my bad. Okay, give me a minute, guys. I have to I have the wrong path for the file, so I'll just copy paste the path file and then we'll be good to. Okay. So here is the data. And then we did the describe, we did the tick info. Okay. And then we want to see the visualization of the graph. For that, we are using Seaborn as SNS and we are drawing a multivariate graph, that is a heat, to analyze the data. Okay. Here, the middle blues are the one, the reading of one. Okay. Means the day and day, year tag number and year tag number. Okay. That doesn't come into account. Okay. The correlation of these is minus 0.2, 0.0, 0.2 is the color of each of these related to other things. Okay. So here 0.2 to 0.4, we have age with year tag number. Okay, the correlation of it. So that is how you read a heat map. And then we have from sklearn pre-processing, we imported label and count encoder. So for the column, we already know how many columns we have. Day, season, farms, year tag number, sex, age, stocking density, body condition score, and tick distribution percent. So next, when we come to the unique values in the columns, we want to know the unique values. So these are the unique values in the columns. In day, we have all of them as unique. In season, we have 4 seasons. Farms, we have 30 farms. And year tag number, we have 29 year tag numbers. As I told yesterday, year tag numbers might repeat from each of the farms we have taken. The year tag number, each of the farms has their order. So we might select the same year tag numbers from their particular forms. Next is the sex. So we have two types, that is male and female. Then we have age, that is 5 unique, because as we know they have a shorter lifespan, so we mostly have the repeated age. Stocking density is 17 different unique stocking density values. Body condition score, it's a range of 1 to 10 we have taken. And distribution percentage. Next is we are trying to do the encoding for season, farms, and sex. Okay, how does label encoding work? Is they have their own particular numbers given to them. So as we have, suppose if I take an example of season, we have 4 different seasons. So each of these, summer gets 1, winter gets 2, rainy gets 3, and spring gets 4. Okay, so that is how the season label encoder works. We have it here. Season number is, it started from 0, 1, 2, 3, and 4 might be somewhere down, as we're not seeing the full data set. So that is how, and it also done for farm number and sex number. And for defined norm function, we are defining its normal function with a formula I minus I minimum divided by I max minus I minimum. Then we return X. So then, since we don't want season, farms, and sex, we can drop them. Okay. Here then we have year tag number, age, stocking density, body condition score, distribution percent, season, farm, and sex number. So these extra season, farms, and sex where we have it are these with full rows and columns. Since we have already done the label encoder and we got the different columns with the label encodings to them, so we don't need these 3 columns anymore. Yes. Here you can see for sex number, it's the given as 0 and 1. So 0 is male and 1 is female, or vice versa. So that is how label encoding works. So now here we are eliminating season, farm, and sex because of that. Since we already have the encodings values. Then we have the cluster. Now, as we have modified the data according to our likings, we go into cluster. So we call the cluster using sklearn cluster import k-means. And we also import matplotlib as plot to show the clustering distributions. We use total within sum of squares, which we discussed yesterday, between sum of squares, within sum of squares, and both of that will be total within sum of squares. Okay, so creating an empty list for all the k values we take. Okay, as we discussed yesterday, in the last session, within sum of squares, okay, k has to be given manually. Okay, we have to know our data and we have to give it manually on how many k means clusters you can get. So here we are giving that the list range is from 1 to 9. We can't cross 9. Okay, the case list has to be from 1 to 9. And for k, for I and k, we take k means clustering as I, and then we fit it for the data set, and then we take the total within sum of squares and append it for k-means inertia. Okay, so the total within sum of squares is this much, the value. And then we try to plot with the k and total within sum of squares. We plot the graph with label. Plt.x label is number of clusters. Plt.y label is total within sum of squares. So this is how the graph we get. This is the number of clusters, that is 1 to 8. And then this is the total within sum of squares. So this is the graph. And from echelon matrix, we import silhouette score. So range and clusters is from 1 to 9. Silhouette average, we have taken it as null. For number of clusters in range and clusters is 1 to 9. We are using k-means, and one k-means n clusters is equal to n clusters, number of clusters. So k-means dot fit for the data we have. So cluster labels is nothing but k-mean labels. So silhouette average dot append. You are appending the silhouette average. So silhouette score for the data, that is, and tick labels. So here the range and clusters, that is 1 to 9, and the silhouette average, which is empty here, empty list, but you have appended it with silhouette score and silhouette score of the data and cluster labels. So this is how you get the graph. Silhouette analysis for optimal k. What this graph represents is, you take the highest value, you say that the highest value which you got here, that would be between 4 and 5, but you can take a max of 4 or 5. K is equal to 5 or k is equal to 4. You can do your clusters in that range. Okay, that is how you can use silhouette score to test out your data, test out your k on where you can give it a range to. Okay, so I can take my clusterings. I can make for this data, I can take a clustering of k is equal to 4 or k is equal to 5. Okay, so here model k means your n clusters I have taken the n clusters as 5. Okay, I'm fitting the model for the data. Take. Okay, so here the model dot labels, and then I am getting the series. I'm converting into series for this model. It's in an array, so I'm converting it into series. So tick cluster is equal to MB, and then the data. I got the cluster here. Okay, 0, 4. I have different clusters according to where it belongs to, according to the data. It has divided my data into clusters. As you can see, I have on the head and tail, I have 0 and 4. So in between the data, there might be 1, 2, 3. Okay. So that is how you do your k-means clustering. Hope you all got a idea of how k-means clustering is done. Now, we'll see another use case on, let me open up my file. Animal behavior. Okay. What exactly is this animal behavior? So, in many areas of animal behavior research, improvements in our ability to collect large and detailed data sets are overstripping our ability to analyze them. Okay, these diverse and complex and often highly dimensional data sets exhibit nonlinear dependencies and unknown interactions across multiple variables and may fail to conform to the assumptions of many classical statistical models. So, the field of machine learning provides methodologies that are ideally suited for a task and extracting knowledge from these data sets. So, if we go to the here the recent technological advances mean that large data sets can be collected on the moment in that particular moment. So fine scale motion, social interactions, vocalizations, and psychological responses. Okay, these come under animal behavior and responses of individual animals. So, conversely, the logistic difficulties of collecting replicated data, especially from wild populations, mean the sample sizes are small, even though data on each individual may be rich, with many hundreds of factors to consider. These complex datasets generated from different sources, such as images and audio recordings, may fail to confirm the assumptions of many classical statistical models. Moreover, unknown nonlinear dependencies and interactions across multiple variables make it unclear what type of functional relationship one should use to describe such data mathematically. Animal behavior researchers are thus in position where automatically collected detailed data sets is becoming commonplace. But extracting knowledge from them is a daunting task, mainly due to lack of accessible analytical tools to them. Machine learning offers complementary data modeling techniques to those classical statistics. So basically in animal behavior, ML approaches can address otherwise interactable tasks such as classifying species, individuals, vocalizations, or behaviors within complex data sets. This allows us to answer important questions across a range of topics, including movement ecology, social structure, collective behavior, communication, and welfare. So, this is how ML can address different objectives in numerous distinct fields of animal behavior and is thus becoming a staple approach for novel methods. So, the main aim of this review is to demystify ML, which is typically documented in technical journals and books. So, unsupervised learning methods uncover structures in unlabeled data Okay. Structure means patterns in the data. Method, uncover, structure in unlabeled data. So structure here means patterns in the data that are efficiently different from unstructured noise. Okay, that are noise. For example, the data may be temporarily or spatially correlated or organized in a hierarchical fashion. Okay, so example, transcripts factors that regulate gene expression. This is one of the example. So the dimensionality or identifying groups of observations say sharing similar attributes, that is nothing but clustering, and determining the distribution of the data, okay, in the clustering forms. So we will directly learn or observe what clustering does in animal behavior. The goal of clustering is to find groups that share similar properties. The data in each group should be similar, but each cluster should be sufficiently different. There are three major types of clustering methods. First one is partitioning. Okay, clustering. We have three types. First is partitioning. Here, where the feature space is divided into k regions, feature space, and we have hierarchical, where small clusters are iteratively merged into larger ones. Okay, so or vice versa. And we have model based, where multivariate statistics, distributions are fitted. For distance based methods, similarly between observations and similarly between clusters need to be defined. So here they have presented three popular algorithms of each type, followed by a brief discussion on the problem of estimating the correct number of clusters in the data. So we'll be looking only at our discussion topic, that is partitioning of K regions, that is K means. Arguably, here K-means is most widely used partitioning clustering method. Okay, so example, to group behavioral modes in little penguins. The feature space is divided into K regions as follows. Okay, First is they choose case androids at random or using some prior knowledge. And they, okay, I will just write these down. First one, choose K centroids at random or using prior knowledge. And then second is to compute the distance between centroids. And each data point. Next is to assign each data point to the closest centroid. And fourth is to compute new centroids. So here the average of all the data points in that cluster. Okay, we have to compute new data centroids. That is nothing but the average of all the data points in that cluster. And then the fifth is to repeat 2 to 4 until data point remain the same. So cluster or a maximum number of iterations is reached. Why is k-means popular? Because it is intuitive and computationally inexpensive. However, it is only applicable to continuous data where a mean is defined. There is also no guarantee for a global optimum solution. Thus, the user is advised to start the algorithm at random distant centroids. Okay, this is about k-means clustering. So we also have hierarchical clustering and but that is not the topic we are dealing with. We'll be dealing with some other time. So this is about the k-means clustering and some of the use cases and how it is used in the animal behavior. So now here we complete about k-means clustering. Next, we move on to another classification algorithm, that is KNN. The agenda for KNN will be to nearest neighbor classifier. We'll be discussing about the nearest neighbor classifier, and we'll be selecting k values with 2. Okay, it is a k nearest neighbor. So we'll have to select the k values, and we see whether first near neighbor classifier 2, 1, and so on k nearest neighbor classifier. And we see how controlling complexity in KNN, how we do the controlling complexity in KNN. Okay, and we discuss about the advantages and disadvantages of KNN model. Okay, let's move on. First of all, to get an idea of nearest neighbor classifier, that is K nearest neighbor classifiers. Here K and N is a supervised learning model. So if it is supervised, it is already defined that Y is no. In supervised, we have two types. We have classification, we have regression. In classification, or when do we use classification? When Y is categorical. And in regression, Y is numeric. So, K nearest neighbor, what we do here is, here we are finding nearest neighbor for using data points, or we are finding nearest neighbor. Instead of for, we can say by, using data points. If suppose we have data points and a new data point is added into the dataset, in classification we let go to, or will it be determined with KNN? So how does KNN actually work for any individual data point? Okay. We say that data is always streaming in. So if you have already have a data set with k values, suppose a new data is coming in. So how do you accommodate this data? How do you group this data? Okay. How does KNN actually work for any individual data point? So what does KNN do is it finds distance between the data points and k number of data points, which is for categorizing that is most frequent, assigned to k. So for that to calculate, KNN takes into account of Euclidean distance. Okay, here is one of the example, and here let me take another example. This is also a cluster with, okay. So these both are the clusters. Suppose a data point is coming in here, a data point is here, and how will it know that in which cluster or in which KNN, in which neighbor this data point belongs to, or it has to go to? So in that case, what happens is here a distance called as Euclidean distance, which is used to calculate the distance between 2 points. Here 2 points is nothing but 1 and 2. We can take it as that. Root of x1 minus x2 whole square plus y1 minus y2 whole square. This formula, this data point uses this formula to go into the groups. Okay. For KNN, by default, we take this distance. Other distance matrix can also be considered. Which is used to try predict the future outcomes. Okay. KNN has another name, that is a lazy learning algorithm. When you have a output variable, or you can say it as continuous variable or a numeric variable. So if we take here y is equal to numeric and y continuous, if the output variable is categorical, it works same in case of naive Bayes algorithm. Okay. So here it is to say that the output variable is numeric as well if it is categorical. In naive Bayes, output is categorical. In that case, what we do is we discretize the mean and convert categorical data into discrete data. Okay, this is the basic info of nearest neighbor classifier, KNN. Okay, it is the supervised learning model where Y is known. It is divided into that is classification and regression. Why classification? When to use classification? When we have categorical data. When to use regression? When we have numeric data. And how do you know a data point which is coming in has to go into its represent groups is by using the Euclidean distance. So we also have something called as another name for KNN. This is lazy learning algorithm because lazy learning matlab it learns slowly. Okay. So let's see. Example, text example. Here we have some class. So we have 1, 6, 7, 8, 9, and 0. But here they have given a text example of what class to assign this data point. This particular data point, to which class it belongs. We have some handwritten digits here. We need to classify and assign a number to one of these classes. Looking at the image, we know that there are 10 classes or instances. So it is called as 10 class problem. Okay, 10 class problem. Or can also be said as 10 class classification problem. So what we do here is we classify to what category this particular handwritten digit belongs to. So for that we train a model, and when there is a new handwritten digit, it should be automatically get into one of these classes. Now, in what scenario do we apply this case? Let us think of a wildlife example where animals in the farms are given number tags to keep track of the animals. along with its features like sex, body density, etc. etc. When they want to, so that is given because whenever they want to study a particular animal, they identify it easily and take it for study. There are a lot of studies going on about the methods and improvements made. So, I'm sorry, look at the data. Here we are looking at this data. We have data points of yellow, green, orange, and gray. So you want to classify the gray point into a class. Here there are three potential classes, that is lime green, green, okay, this is taken as not yellow but lime green, my bad, and orange. And next, after looking at the data, you distances using Euclidean distance. So we start by calculating the distances between the gray point and all other points. And you find neighbors. Next, find the nearest neighbors by ranking points by increasing distance. The nearest neighbors of the gray point are the ones closest to data space. Okay, so point distance from gray to yellow or lime green is 2.1 and 2.4, and then from gray to green is 3.1. Okay, and from gray to orange is 4.5. So the ranking for second 3.1 and 4.5. So the nearest neighbor, that is 2.1, this gray point will get added into this lime green data. So photon labels is photon predicted a class label based on the classes of the nearest neighbor. Here the labels were predicted based on the k is equal to 3 nearest neighbors. Here they have done the voting mechanism where two are lime green, one is green and one is orange. So class lime green wins the vote and point gray is therefore predicted to be of class lime green. Okay, that is how you do the nearest neighbor classifier. This 4.5, 2.1 is done. You get the values using the Euclidean distance method. And then you have the nearest neighbor classifier working. It can be explained on the basis of the below algorithm. First, we have to select the number k of the neighbors. Okay. Then we calculate the Euclidean distance of k number of neighbors as per the calculated Euclidean distance. And among these k neighbors, we count the number of the data points in each category. So next is we assign a new data point to that category for which the number of the neighbor is maximum. Then after this is done, our model is ready. So this is basically what is explained. Okay. First you find the k nearest neighbors, and then you calculate the Euclidean distance, and then you find the neighbors according to the shortest distance, and then you assign a new data point to that category for which the number of the neighbors is maximum. Okay, here you saw the lime green has 2 points which is maximum. So there first you have to count the data points in each category, and then we have to assign new data points to that category for which the numbers of the neighbors is maximum. And then after that we put this gray point into that lime green neighbor. So then the model is ready. Next, this is a k is equal to 1 nearest neighbor classifier. Here we have data points of blue and pink. And we segregate these data points. And how do you segregate this data point? Here, k is equal to 1. Okay, let's start from the beginning. Some use cases we are looking at now with the handwritten digit identification is 1KNN. We are looking and trying to understand. We have two classes. They are blue and pink. These are two existing classes we already have here. Okay, and there is a new entry. This big block of square is a new entry that comes up. So we have to use it and find the distance of the new entry. So what we do here is we have to find the distance of the new entry. Will all the points we have here? So here the actual question will be how to find the distance between 2 points. We have something called as distance measure, that is Euclidean distance. And as I mentioned before, we can also use some other distance measures that are Manhattan distance, Mann-Lobis distance, and many more. Okay, by default, here for KNN, we use Euclidean distance. So we can calculate the distance between two data points with any of the distance measures. So we say the value of k is equal to 1. Then we have to find the first closest data value. So they have already, here if you see, they have already circled the closest data point. Yes, this can be this, but as we can see it, this is the closest data point, which is a pink one. Now here, suppose we say our k is equal to 2. We find the nearest two values to the given data point. Here the data points are blue and pink again, but here we have a conflict. If you take it as k is equal to 2, we have both of these with different classes coming. Yes, given data point here, say that one belongs to pink and blue. Now the algorithm is confused. So in these cases, to avoid this scenario, we always take k value as odd numbers. So suppose for this same example, if we take k is equal to 3, okay, we can have a circle like this. Yes. So then the majority here is pink. So we can automatically assume that this block of pink belongs to this data. Okay. So when we assign k values to odd numbers, we can estimate this conflict to a certain extent. If k is equal to 3, seeing the majority, we assign the values to this pink, okay, uh, class. This is when the outgoing value is categorical. That means y is categorical. And we can give an example about a crossbreed between a donkey and a horse. They are called mules. Okay. This crossbreed is called mules. So here, if we have to categorize them into, suppose on a farm, we have separate godowns for donkeys and horses. Okay. And we have something called as mule with us, and we want to only put this mule into one of these godowns or sheds, their resting places. So here, if we have to categorize them into horse or donkey, which one would you choose? For this, we take features of it and consider which it resembles more. Okay, and categorize it into the category. Suppose say it contains a lot of donkey features and less of horse features. We put this mule into the donkey shed. Okay, that is how we do a nearest neighbor. This is the k is equal to 3 classifier. We can see this is a data point x, and we have 3 nearest neighbors. So here, although pink is nearest value, orange, blue, and blue, even though blue is further away, but the majority here is blue. So we take that into consideration and we categorize the X into the blue value. Here, next is the one more simple concept. When we are choosing k value, we have to keep in mind some of the things. If k is equal to 1, the classes are divided into regions and the query record belongs to a class recording, to the region it lies in. Okay, here classes are divided into regions. Okay, and the query record belongs to a class recording, to the region it lies in. So choose data values of k for a two class problem, and k must not be a multiple of the number of classes. So k is not equal to ni, where n is the number of classes, that is I is equal to 1, 2, 3, and so on up to n. These are the points to remember when you are choosing the value, k value. Okay. Let's draw a graph here. Here, the hyper parameter we are dealing with here is the k value. So hyperparameter is that option in algorithm which can change the data. And change in hyperparameter will result in the change of accuracy. So what we do here is we keep changing on hyperparameter. That means we keep on calculating the training accuracy. Okay. And test accuracy. For example, let us assume here the k is value is 21. We do not know that output we get. We have to keep on experimenting. We can start with k is equal to 3, and when we train the model, the training accuracy increases. This is this one. Training set accuracy increases. And validation set accuracy decreases. Okay. So what happens in this is it gets diverged. As you can see, observe here, this gets diverged. This is increasing upward and this is decreasing downward. When the validation data gets diverged, this phenomena is called underfitting. Okay, this phenomena is called underfitting. Before we even talk about overfitting, Let's see if the K value increases the validation accuracy along with the training accuracy increases. This phenomena is called overfitting. Okay. If the training accuracy increases and validation accuracy decreases, this is called underfitting. But in another case where the training set accuracy increases along with the validation set accuracy, then it is called overfitting. And overfitting is also called as, we already learned what is variance and bias, guys. So it is called variance. We can train the model until when the train and validation accuracy gets diverged. We have to, or we can train the model until we get this kind of output. Okay. And one more scenario here is, for this graph, if k is greater less than 21, we call this as underfitting. That means this is there is still room for improvement. So this is how you control complexity of KNN. So the point where increases and decreases, so that line is called the right level of model complexity. We have a sample data of grocery store, or we can say vegetable and food store. Now the ingredient they gave us is apple, grape, orange, green bean, cucumber, and nuts. So they have taken the sweetness of it, crunchiness of it, and food type. Here, apple's sweetness is 10, its crunchiness is 9, and it belongs to the food type fruit. Grape, sweetness is 11, crunchiness is 4, and it's also food type fruit. Orange, 13, crunchiness is 1, and belongs to category fruit. Green beans, sweetness 7, crunchiness 10, and belongs to vegetable. Cucumber and nut. Cucumber is a vegetable with sweetness 3 and crunchiness 10. And nuts, sweetness is 1, crunchiness is 1, and it belongs to protein food type. So with this data, what do they do? So we have a graph here with y-axis referring to how crunchy the food is and x-axis referring to how sweet the food tastes. We have three categories of data, that is vegetable, protein, and fruit. Vegetables, we have lettuce, celery, carrot, cucumber, and green beans. And in fruits, we have apples, pears, grape, orange, and banana. And in protein food, we have nuts, bacon, shrimp, fish, and cheese. Okay, they have given a data point or a type, that is a tomato. And they have told to, with the help of this data, which the model learned, we have to, the machine or the algorithm has to be able to categorize this tomato into its respective category or group. Okay, so here they have taken k is equal to 4. We have to first identify whether it's a vegetable, whether it is a nut, or whether it is a fruit. Okay, for that, they have given us tomato. We have to see the sweetness of tomato. Tomato is a bit sweet because it is ripened into a red color. Yes, so we can take it as 10. And the crunchiness of tomato is 5 maybe, because it has thick, juicy matter in it. And food type, according to the study and measuring the distance, here we have the closest distance as nut, green bean, grape, and orange. And we do a distance matrix, that is Euclidean distance. We get it in the category of fruit. So the dotted lines, which has the more number of lines to its, to which category is fruit. So the tomato belongs to a fruit type. Okay, so that is how you classify the data point. And advantages and disadvantages of KNN. Advantages of KNN algorithm is no training phase. It can learn complex models easily, and it is robust to noisy training data. Okay, it does not require any learning training phase because it is a lazy learning algorithm, and it can learn complex models easily. And it is robust to noisy training data. The disadvantages of using KNN algorithm, it determines the value of parameter k, can be difficult as different k values can give different results. Okay, if k is equal to 1, we get a different result. If k is equal to 2, we get a different result. And the same k is equal to 3, we get a different result. Yes, so determining the value of parameter k can be difficult in this scenario. And it is also hard to apply on high dimensional data. If you have very high dimensional data, we can't categorize it into groups, and computation cost is also high. As for each query, it has to go through all the records, which takes ample amount of time. Okay, the whole data set, it might be a regular data or a big data, whatever it might be. if you have a query, and if you give a query to it, it has to go through all the data records, which takes a lot of time and computational power. Okay, where you can say n is a neighbor number of records. If we maintain a priority queue to return the closest k record, then the time complexity will be O log k into n. So these are the disadvantages of KNN algorithm. Tomorrow, we'll look into some of the use cases as we did today regarding KNN in the next session. And we'll also discuss the next algorithm where where the wildlife is making use of. Thank you.